Okay, differentiation. First thing, x squared minus 4x plus 1. The x squared goes to 2x, the minus 4x goes to minus 4, and the plus 1 differentiates to 0. So dy by dx is equal to 2x minus 4. The coordinates of the turning point. A turning point is a point on a graph, if you have a graph that looks like this, where the gradient equals 0. So that would be here, 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 or here. Those would all be turning points. And if at the turning point it peaks, that's a maximum. So that would be a maximum. If it dips, that would be a minimum. So there's a minimum, there's another maximum, and there's another minimum. Now, obviously this graph is a quadratic. It's a positive quadratic, so it's not going to have lots and lots of turning points. But to find the turning points, it's where the gradient, which is dy by dx, tells us is the gradient function. It's where the gradient is equal to 0. So if the gradient function for this graph is 2x minus 4, we just want to find out where 2x minus 4 equals 0. And of course that means that 2x equals 4, so x is 2. But it does ask for the coordinates. So if we're going to have a coordinate, we need an x value and a y value. Where does the y value come from? Well, it comes from the original equation. Y equals x squared minus 4x plus 1. So y equals 2 squared, which is 4, minus 4 lots of 2, so minus 8, second is minus 4, plus 1 is minus 3. So the coordinates are 2, negative 3. Is it a maximum or a minimum? The easiest way to do this one is to look at the graph. It's a quadratic, and quadratics are either happy face or sad face. Reason you can tell whether they're happy face or sad face is whether the number in front of x squared is positive or negative. In this case, you've got just x squared, which means there's an invisible 1 there. So 1 lot of x squared into the x squared value is positive. So we have a positive quadratic, happy face, and positive quadratics have a minimum. So that's the justification. You can say positive quadratic therefore minimum. If it's a sad face quadratic, if it was like minus 3x squared or minus 7x squared or minus x squared, then the turning point would be a peak maximum. Find the equation of the line at symmetry. Now this is a tricky one. One way of doing this is to complete the square. X squared minus 4x plus 1 is the same as x minus 2 squared, which gives us x squared minus 4x plus 4. And then to get from the plus 4 to the minus 1, we'd subtract 3. So the graph could be written as x minus 2 squared minus 3. Now if it's x minus 2 squared, this bit tells us that we've moved it 2 to the right. So effectively when x equals 2, that's the minimum point of the graph. So that becomes our line of symmetry. Takes a long time to justify that one. Just know that if you have to do that question again, it's easier to complete the square.